Alright, welcome to lesson number 11. Now we're looking at all that piece and piece of reduction problems we've been doing. Now we're putting them all together. Yeah, and the first one we're doing via reduction formula, right? So, we say reduction formula, we're going to be working with the quadrants. So you need to know 360 plus theta is in first quadrant. Theta minus 360, 90 minus. What is in the second quadrant? What's in the third quadrant? What's in the fourth quadrant, right? Then we use the cast rule, meaning cos all sine tan. So the only cos is positive, everything is positive first quadrant, sine positive second, tan positive third. You can pause your video here and take it down, make your own. But these are most of the items we're looking at. Some I've left out, right? But that's your cast rule, right? They say all sexy teachers are colored, or all stations to Cape Town. What a beautiful city. Problem number 1 can be sine theta minus 180, tan 360 minus theta times sine 90 minus theta, cos squared theta plus 180. So that's generally you get 2 reduction problems. I'm now doing the first one, normally for 6 marks in exam each. So theta minus 180. If theta is in the first quadrant, I'm subtracting 180. I'm moving 2 quadrants in a clockwise direction. So I end up in quadrant 3. And in quadrant 3, sine is negative. Tan 360 minus theta falls in the fourth quadrant. In the fourth quadrant, tan is negative. Sine 90 minus theta. 90 minus theta in the first quadrant. Everything is positive, but 90 changes sign to cos theta. Cos squared theta plus 180. So if I take theta in the first quadrant, I add 180, right? How many quadrants am I moving? 2, right? So 2 quadrants. The third quadrant, cos is negative. But take note now, because it's squared, I write negative cos theta in brackets and the square outside. Soon as you see sine and cos given with tan, we will always write tan theta as sine theta over cos theta, right? You get 1 mark for doing that. So there I have now. First got rid of my negatives. Negative times negative is positive there. And negative squared means negative times negative become positive. Place of tan, I wrote sine theta over cos theta times cos theta over cos squared theta. Right? You should see now sine theta or cos theta. Cos theta would cancel, and I'm left with sine theta times sine theta, bottom cos squared theta. Sine times sine will give me sine squared theta, and sine squared theta over cos squared theta gives me tan squared theta, right? I assume you know that's called a quotient identity, right? Look at problem number 2. Cos squared 90 minus theta, tan 180 minus theta, cos 180 plus theta, sine 180 minus theta. Right? So 90 minus, first quadrant, but 90 changes cos to sine. Everything is positive in the first quadrant, so that simply becomes sine squared theta. 180 minus theta falls in the second quadrant. In the second quadrant, tan is negative, so that's written as negative tan theta. See, I put them in brackets, ne? If I don't put them in brackets, this would read sine squared minus tan theta. In brackets, this reads now sine squared times negative tan theta. Right, and then cos 180 plus theta, third quadrant. Third quadrant, cos is negative. So that becomes negative cos theta. Again in brackets, 180 minus theta. Second quadrant, sine is positive, so that simply becomes sine theta. So I have sine squared theta. Tan we'll always write as sine theta over cos theta, and there cos theta. Take note, I somehow get rid of the negatives as soon as possible, so I don't make an error along the way. Negative times negative is positive, so you see no negative sign. Alright, so sine squared plus sine theta would give me sine cubed theta, and 1 over cos theta times cos theta cancels, so I only have sine cubed theta on the top, sine theta at the bottom, and when I divide, sine cubed divided by sine theta gives me sine squared theta. You see there, they say simplify to single trig ratio. So I only have sine. I don't have sine, cos, and tan. Right? Let's look at the next problem. Alright, now problem number 3, they simply say simplify. Given me cos squared 180 minus x, tan squared 360 plus x, sine squared 180 minus x. So 180 minus x fall in the second quadrant, only sine is positive there, so cos becomes negative cos x, but I move the square outside, right? There, tan squared 360 plus x, 360 plus x falls in the first quadrant, so that is positive tan x, but there again, as you see, I can move the square outside. 180 minus x for second quadrant, so sine is positive there, and that becomes sine squared x. There, negative times negative, positive, cos x times cos x, cos squared x. Tan squared x there can be written as sine squared x over cos squared x. Cos squared x and cos squared x cancel. So I have sine squared x left on the top and the sine squared x from the bottom. Anything divided by itself equal 1. Right? So hope you follow, and there I've simplified that problem. If you're liking the lesson so far, please like, share, and subscribe. Right? You won't be able to stay up to date if you don't, but I'm going to be loading up your whole year's work, lesson by lesson, what you should be doing in class. Let's look at problem number 4. Right, now I have sine 180 plus x, cos negative x, tan negative x plus sine x minus 360 times sine x minus 180. Alright, so 180 plus x, third quadrant. In the third quadrant, sine is negative, so that becomes negative sine x. Cos negative angle falls in the fourth quadrant. Fourth quadrant, cos is positive, so that becomes cos x. Tan negative x, fourth quadrant, so tan in the fourth quadrant, negative tan x. X minus 360 means I started first quadrant and I rotated back to the first quadrant, so that becomes sine x. X minus 180, right, started first quadrant, rotated clockwise 2 quadrants, third quadrant, sine is negative. Right, so there, number 1, it left the top as it appears. Always get 1 mark for writing tan x as sine x over cos x. Then negative times positive become negative, sine x times sine x, sine squared x. Right, so from there I can say sine x cos x over 1. Change division to multiplication and invert the bottom fraction. So cos x goes to the top and sine x to the bottom minus my sine squared x. Now you should see sine x and sine x would cancel. And I'm left with cos x times cos x minus sine squared x. Cos x times cos x gives me cos squared x. Right? Now simplify as far as possible. We generally try to have only one trig ratio, either cos or sine. Here I decided to change sine according to square identity. Sine squared x would be 1 minus cos squared x. Could have changed cos squared x also to 1 minus sine squared x. But yeah, I went that way. So there, negative times negative gives me positive. So cos squared x plus cos squared x becomes 2 cos squared x. And there, negative times 1, negative 1. Right? Please like, share, and subscribe. Continue practicing. As I said, this is basically how we're going to test an exam via reduction formula. The next lesson, I'm now going to be looking at what we call special angles.